Planes are a critical part of today's world. From shipping to travel, they allow things and people to get to and from places that previously would have been nearly accessible, and one critical part of every aircraft is the fuel. Typically, fuel is stored in tanks located in the body, called the fuselage, and wings. Many aircraft, including the Boeing 777, use an ultrasonic sensor to determine the current fuel quantity in the tanks. The sensor emits ultrasonic waves, and the sensor determines the time for the waves to travel to an object, in this case, the top of the fuel in the tank, called the fuel line, to determine the distance from the top of the tank to the fuel line, which is used to calibrate the overall density in the tank. This method is usually considered one of the best ways of measuring fuel quantity, as it is an instantaneous measurement instead of relative. Additionally, if everything is working properly, it is more accurate and less prone to inaccuracies than other systems. However, that if is why we are here today. For this metrology story, we will examine why the Federal Aviation Administration recently proposed requiring modifications to the Boeing 777 fuel system. Due to an error calibrating the velocity of sound in the FQIS, the reported fuel quantity for some aircraft was different, typically less than the actual quantity. And while there are redundant systems to measure this, the main one is connected to the engine fuel usage, which only starts measuring after takeoff. As you can probably guess, this is a little late to find this out. While there were not any crashes related to this issue, it did result in at least 25 in-service events. While both the FAA and Boeing have issued changes since this was discovered in 2020, they have thus far only meant to be temporary holding actions. However, on March 21st, 2022, the FAA issued an airworthiness directive that would require a software update as well as replacing outdated FQPUs with an updated model with new software already uploaded. As for the impact this will have, it will actually be relatively small. While 6.7 million may sound like a lot, it is minimal to fix the entire fleet compared to the average lifelong maintenance cost of a single aircraft, especially since updates to hardware and software are likely to come soon anyways. And due to the lack of crashes and injuries from these incidents, the consequences and coverage will be minimal to Boeing, since, as we all know, Boeing has the best reputation these days. However, this situation is still a good case study for designing and maintaining measurement systems. It is important to have a thorough understanding of sensor mechanics and possible failure modes. With this knowledge, it is important to cover these possible failure modes with redundant systems and warning and detection notifications early enough to be useful. Finally, when implementing improvements and/or changes, try to use components to do the checks instead of human beings, as components are less prone to unpredictable errors. Plus, maintenance crews already have enough work to do and don't need additional tasks to accomplish in such a short amount of time. Thank you for listening. If you want to look into this more, please check out the resources below.